Have you ever really, and I mean really, thought about the water that comes out of your tap? We turn the handle and poof, there it is. Clean, safe, ready to go. But the journey that water takes to get that pure, well, that is an incredible story of technology, of massive scale, and of mind-blowing precision. So let's get right into it.
It seems like a simple enough question, right? But the answer is way more interesting than just, dams and reservoirs. The real magic, the part that gets water truly deeply clean, happens on a much, much smaller scale. And sometimes, it's happening a lot closer than you'd ever guess.
Yep, that's right. For a whole lot of us, that final, crucial step to getting ultra-pure water happens right there, in our own homes, usually in a little compact system tucked away under the kitchen sink. This is exactly where our story starts, at the micro level.
Okay, so before we can wrap our heads around the massive industrial systems that literally power our world, we've got to understand the core principles they're built on. And honestly, there's no better place to start than with a standard everyday home filtration system.
So how does this whole thing work? Well, let's just follow a single drop of water on its little adventure. First, it comes in through the inlet, and boom, it hits the pre-filters. The first one grabs all the big stuff. We're talking rust, sand, any grit. Then, it flows through a carbon filter, which is great at grabbing things like chlorine that make water taste and smell funky. But the real star of the show, the absolute hero, is the next stage, the RO membrane. We'll get back to that in a sec. After that, it gets a quick final polish from one last filter, and then it's on its way to the faucet, perfectly pure and ready to drink.
So, that star of the show I mentioned? That's reverse osmosis, or RO. Here's the deal. Imagine a filter, a screen, that is so incredibly fine that only pure water molecules can squeeze through. That's the membrane. By applying pressure, we're basically pushing our tap water up against the screen. The tiny water molecules pass through to the other side, but all the bigger stuff like dissolved salts, heavy metals, all kinds of impurities, they get left behind and just flushed away. It is an absolutely amazing way to purify water right down to the molecular level.
All right, now that we've got the basics down pat, let's zoom out. I mean, way out. We're leaving the kitchen behind and heading straight to the factory floor to see how these exact same ideas get scaled up into something truly massive.
And this is really the core question, isn't it? What does it take to apply that same molecular level cleaning, but for thousands or even tens of thousands of gallons of water every single day? The principle is the same, sure, but the scale, well, it's not even on the same planet.
And this right here just says it all. The difference is just, wow. On the left, you're looking at the industrial-grade version. Those big white tubes are pressure vessels made of super strong fiber-reinforced plastic, built to hold RO membranes under immense pressure 24/7. And on the right, that's the little plastic housing from under the sink. It's the same basic job, but a totally different world of engineering.
And the numbers really tell the story here. I mean, check this out. Your home system might make about 50 gallons a day. That's great for your family. An industrial system like this one, it can crank out over 44,000 gallons a day. You go from lightweight plastic to heavy-duty stainless steel. You go from low household water pressure to needing powerful, high-horsepower pumps. And you go from something that fits in a cabinet to a machine the size of a car. It's a huge leap.
And it's not a one-size-fits-all kind of deal. In the industrial world, you need a whole toolbox of different purification technologies for different challenges. It's not just about making water clean. It's about making the exact right kind of clean water for a very specific job.
Take this, for instance, seawater desalination. This is probably one of the toughest jobs you can ask of RO technology. These systems, sometimes built right inside shipping containers so they can be dropped anywhere in the world, have to be incredibly tough and reliable to turn the ocean into fresh, drinkable water. That's pretty amazing stuff.
But RO isn't the only tool in the box. There's also something called ultrafiltration, or UF. Think of it this way. If RO has a super fine screen, UF has a slightly less fine one. It's perfect for catching bigger things like bacteria and viruses. Because of this, you'll often see UF systems acting as a kind of bodyguard for the RO membranes, clearing out the bigger threats first so the delicate RO membranes downstream don't get damaged.
And even before the water gets to any of those advanced membranes, it has to pass through the first line of defense. These are the absolute workhorses of the whole operation. Heavy-duty filter housings made from solid stainless steel. They're the industrial big brother to that little sediment filter under your sink, but they're built to handle unbelievable amounts of water and pressure without even breaking a sweat.
So we've seen the tech, from the tiny to the truly massive. But why does it matter? Why is this all so important? Well,
This isn't just cool engineering for the sake of it. This technology has a huge impact on our daily lives, usually in ways we don't even see.
I really like this motto from Deng Yuan, one of the companies that makes all this equipment. Quality water is quality life. It just nails it, doesn't it? Whether we're talking about water for one family's drinking glasses or for a huge factory, the goal is exactly the same, making sure the quality of the water leads to a better quality of life and industry.
I mean, just think about it for a second. The medicines we take, they require ridiculously pure water to be made safely. The microchips inside your phone. A single tiny mineral deposit from impure water could ruin an entire batch. The food you eat, the drinks you enjoy, all of it depends on these massive, super reliable water purification systems. This technology is truly the invisible backbone of modern life.
So, from a simple filter under the sink to giant desalination plants that can quench the thirst of a city, this technology has totally reshaped our world. And as the global demand for clean, safe water just keeps growing and growing, it leaves us with a really big question. What's next? What new innovations are going to define the future of water purification? And how are they going to help us meet the challenges that lie ahead?